So the components of a suction dredge, you have the nozzle shown here in the picture. The nozzle is the end of the hose. It's either powered or non-powered. Powered is called a jet nozzle, where it incorporates a jet into the nozzle. It's typically a hard pipe with a handle, so that we can the diver can suck up rocks, and sometimes it'll have a curb on it, sometimes it'll have floats on it. That connects to the hose, which is this gray thing or that orange thing. The hose carries material up to the surface. Most dredges are classified by the size of their hose. So if it's an 8-inch dredge, it'll have an 8-inch inside diameter hose, or a 10-inch dredge has a 10-inch inside diameter hose. That typically connects to a jet. This is a jet. It's a ejector jet pump, also known as a venturi. Pressurized water from the water pump gets shot into 1 to 4 jets, sometimes more, and it entrains the main water from the hose through an ejector jet process. This sort of jet pump allows it to pass material the same size as the hose. You're not restricting the material size as you would with a trash pump or a slurry pump. So that's the main advantage. An 8-inch dredge can pass 7-inch rocks without having to have a massive pump. The next step is the flare. So you've sucked up all this material, it's entraining in the water, and now you need to slow it down. So you use a diffuser or a flare, which takes and slows the water down before it hits the sluice box. Not really shown here. So that the water goes, and you want to slowly increase the cross-sectional area of the water, decrease the velocity, while still maintaining laminar flow. If you flare out too fast or diffuse too fast, the water will separate and cause turbulence inside the flow, which decreases efficiency. I already mentioned the water pump. So there's various types of water pumps, which are usually high pressure, high volume water pumps, which power the jets. Pretty standard technology. I can go into more details if anyone really wants to know. The grab dredges, there are very similar to land operations. You have an excavator bucket, some sort of excavator bucket, either a scooper or a clam, and then it picks up and it drops into a standard wash plant. The wash plant will either have a shaker screen or a trommel or both, and then a sluice box. All types will have a sluice box, or some will have a centrifugal recovery system, such as the Judy Ann here. They'll usually have spuds or tracks in order to maintain their station keeping, so that the digger can dig against something. So you can see here the J. Cashman barge, which is now for sale in Seattle, had very large spuds. The Christine Runches here are detached for the winter in this photo, and Judy Ann has, of course, her spuds. The jack-up barges jack up off the water, and they use very large jack leg spuds and hold the entire platform stationary and can actually support the weight of the platform. I think those are 3-foot diameter spuds they use for their jack legs. This is the sluice box design is pretty important, because most of the recovery systems used in offshore are sluice boxes. Everyone uses a gravity recovery system. No one uses chemical recovery. Chemical recovery is used in hard rock mining, where they use leaching and other chemicals to remove the gold, to dissolve the gold and extract it, whereas we stick to placer gold. So it's already free gold. We don't need chemicals to free it from the rock, but we need to use some sort of technology to separate it by gravity. Luckily, gold is about 19 times heavier than water and about twice as heavy as any other material that it's found with in Nome. So sluice boxes work well, as do centrifugal recovery systems. This is from the Clarkston study, which used radioisotopes to track gold particles through sluice boxes. And these are cross sections of different dredge or sluice box configurations. The most popular in Nome is the heavy metal grading in Figure 5 using expanded metal riffles. He used 4 pound per square foot raised expanded metal. These others are riffles of different. He tested all sorts of different configurations and of riffle designs, and he likes most that raised expanded metal, which for the type of gold found in Nome seems to be the most ideal. So the land offshore Nome is controlled by the state of Alaska out to the 3 mile line, is owned by the state of Alaska, and has been released by competitive bid to the public. So it was offered to at competitive auction, and the public was able to bid on it and win. And if you win the lease, you get it for a certain amount of time. So approximately in 1962, approximately 22,000 acres were auctioned off. I couldn't find the exact information prior to about 2000, so these are approximations. Sometime after the BEMA left in 1990, the number of acres dropped down to about 8,000, which was purchased by K&S of Leasing, whose principal is Norm Stiles. About 96 or so, or 97, the east wreck area was opened up to 8-inch dredges and smaller. It would look shown in blue, and then in 2010, the west wreck was also added, for a total of about 500 acres. The 1999, there was a lease sale. Again, that total is approximate there in yellow, and there are, I think, 3 leases remaining from that 99 lease sale. In 2010 and 11, those leases were expired or contracted, and the 8,000 acres that K&S Leasing held was contracted down to 2,000 acres, and then most of that acreage was reissued in the 2011 lease sale shown in green, whose leases expire in 2011 or 2021 or 2022, or can be converted to year leases, assuming there is continuous production, whatever that means at the time. So the total number of acres is approximately 27 to 30,000 acres, which is up from the 22,000 that it has been since 1962. The Nome offshore area mining leases are shown in this map. These various colors for various groups. I'm not sure who added those colors. You can see that the farthest they extend is that 3 mile line, and they go east of Nome several miles and west of Nome about 12, 14 miles. If you compare this to the earlier leases from 1962, you'll notice that that fewer of them go out to 3 miles, and they go out farther east and west. And if you look at compare this to that glacial thrust map, it basically covers the glacial thrust map. There wasn't enough interest for DNR to auction off these other leases, so they held them in reserve so that they could have a lease sale prior to 2022, if there's enough interest, but there has not been. So this is the K&S Leasing, which is now owned by Phoenix Marine, are shown here from the 1962. These are the only remaining 1962 lease tracks. You got these purple ones are from the 1999 lease track, and all the others are from 2011, I believe. There's also some two-stake on land claims along the shore, but those do not extend more than a 1/4 mile offshore.